Hello everyone, in this video I will be solving one complete paper of M1, Edexcel IAL Mechanics 1 WME0101. This is the paper of M1 May 2021. So before solving the paper, if you need to review the individual topics, in that case you can check out this video M1 in 45 minutes where I have already discussed the basic concepts of each topic. So I will add the link in the description box. There are 3 more videos on vectors, so you can get all the related links from the description box and review the topics first. So let's get started. So question number 1 is from the topic momentum. So in this math we have 2 particles. Particle P has a mass of 3m, then we have a second particle Q with a mass of 5m. So the particles are moving towards each other and they are moving in opposite direction. Then they will collide. Immediately before the collision, the speed of P is kU and the speed of Q is 2u. So before the collision, they are moving towards each other with the speed of kU and 2u. Immediately after the collision, the speed of P is u and the speed of Q is 3u. So after the collision, the speed are u and 3u. The direction of motion of Q is reversed. So initially Q was moving towards left, and since the direction has reversed, so now Q will move towards right. But we do not have any idea about the direction of P. So the scenario before the collision and the after the collision are given here. So let's start with the very first part. We need to calculate the magnitude of the impulse exerted on Q by P. So we need to work with this particle Q. So if we just look at this particle Q was actually moving towards left, and then particle P hits particle Q towards right. So basically Q feels a force towards right. So the impulse here exerted on Q is towards right. So for that reason, I will take right side as positive direction. So I'm selecting right side as positive. So the formula for the impulse is this, which is basically the change in momentum. So since we are working with particle Q, the mass will be 5m. I have selected right side as positive, so this direction is positive, it's towards right. But the initial direction is towards left, which is opposite to my selected direction. So that's why minus 2u. So if we substitute u as minus 2u, minus minus will give us plus 2u. So for part A, even if you have selected the opposite direction, left side as positive, in that case you will get a negative 25 mu. But then again, we have to find the magnitude, so the final result should be 25 mu, irrespective of the direction you select. So let's start part B, where we need to find 2 possible values for K. For part B, I will work with the particle P. Impulse is actually equal and opposite. So the value of impulse exerted by Q on P is also 25 mu. To solve part B, I will find the impulse exerted on particle P. But this u, we do not know the direction of particle P after the collision. So that's why we need to solve this problem twice, considering that P actually moves towards right. Even after the collision, it moves in the same direction. And then for the second time, we will solve assuming that the direction of P has reversed. So that's why we will select a positive u and then we will select a negative u for 2 different situations. So if we need to calculate the value for impulse, mv minus u for particle P, P was moving towards right and then Q hits P towards left. So that's why left side, I'm selecting left side as positive for particle P. So m is 3m So let's assume that P is moving towards right. So I have selected left side as positive, so this one should be negative, so minus u is the final velocity. Then the initial velocity is towards right, which is opposite to my selected direction, so that's why minus will give us plus ku, and the impulse is 25 mu. So solving this equation will give us the value for k. So we will solve this math again, considering that P actually, the direction has been reversed and it's moving towards left. Impulse exerted on particle P by Q is towards left, so that's why I will still select left side as my positive direction. So impulse is 25 mu. M is the mass, which is 3m. I have selected left side positive, and for this case we have assumed that P is moving towards left, so that's why this is towards left. I have selected left side as positive, so this should be positive u. But the initial direction is towards left, so that should be minus. Initial direction was towards right, sorry. So towards right, it should be minus. So minus will give us plus ku. So solving this will give us the second value of k. So we're done with number 1. Let's start number 2. A car moves along a straight horizontal road with constant acceleration, and at time t equals to 0, the car passes point A with a speed of u. So assuming this is t0, this is the starting point A, so the initial speed is u. In the first 3 seconds, after passing point A, the car travels a distance of 20. So if I assume this point as the second point, t is 3. So far, the distance traveled is actually 20 meters. In the 4th second, the car travels 10 meters. So if this is t equals 4, in this 4th second, from t3 to t4, in this 4th second, distance travel is 10 meters. The speed of the car as it passes B is 20. So we can assume that this is the final point B, and the final velocity here is 20 meters per second. And find the time taken for the car to travel from A to B, as in we need to calculate the total time duration. So for that, we can actually use the formula V equals U plus AT. So if we consider A as the initial point and B as the final point, we need the value for U, A, because V is actually 20. Only then we can find the value for T. So at first, we need the value for acceleration and the initial velocity at point A. So considering the first 3 seconds of the journey, if I use the formula, distance equals ut plus half at square. Distance travel is 20. U is unknown, t is 3. We do not know the value for A, then t is 3. So from here we will get an equation. So this is an equation of U and A. So we will repeat the same process for the first 4 seconds of the journey. So S equals ut half at square. The total distance is 20 plus 10, 30. Time is 4. Then we have 4 square. So 4u 8a. So if we just factorize this, we will get 50, 30 by 4 u plus 2a. So if this is equation 1 and that's equation 2, solving this two simultaneous equation will give us the value for u and a. So from equation 2 we can find a value for u. So a is 5 by 3. So we can just substitute the value for a here to get the value for u. Now that we have the value for a and u, we can actually apply the formula v equals u plus at. So a is my initial location and b is the final. So final velocity v is 20, u is 25 by 6, a 5 by 3. So solving this will give us the value for t. So t is 9.5. So number 3 is from the chapter vector. We have three forces F1, F2, F3, and these three forces act on a particle of mass 4. Given that P rests in equilibrium on a smooth horizontal surface, find the angle between the direction F3 and the direction ij. And the direction minus j. So for that, we need the value for F3 first, right? Because F3 right now is in terms of A and B. We do not have the value for them. So the first step is to calculate the value for A and B. Since the particle is in equilibrium position, so that's why the resultant force should be 0. Since these three forces are balanced. So I will use this F1, F2, F3. Sum of these three forces should be 0. So next I will just substitute the values for F1, F2, F3. Next we will just combine all the I related values in one bracket. So 5 minus 3 plus ai. Then we will select all the j related values, the coefficients of j in another bracket. So 2, 1, b. So comparing right side and left side, we can see that if we pick the coefficient of I at the left side, it's 2 plus a, but at the right side, we do not have any term related to I, right? So the coefficient, we can imagine it as 0i, 0j, because we do not have any value at the right side. So 2 plus a equals 0, equating the coefficients from both sides. So that will give us the value for a. Similarly, if we compare the values for j coordinates, so 3 plus b equals 0. So that's b equals minus 3. So now that we know the value for a and b, this is actually F3. So F3 is basically F3 was ai, b, j. So this is the force F3. So if I just draw this one, minus 2i, so at the left side 2 units, then minus 3, 1, 2, 3 units downward. So the triangle including this F3 should look like this. So we have 2 and 3. So from this one we can actually find this theta. Tan theta is opposite by adjacent. Tan inverse of 3 by 2. So 56.31. But the question actually was that we had to find the size of the angle between F3 and the direction minus j. So it's like we have positive I at the right side, negative I, then positive j, negative j, this axis. So if we need to calculate the angle of F3 with minus j, this is the angle we are talking about, and this total angle is 90. So if we need this angle, the angle with the minus j, this should be 90 minus theta. So this is the theta. So that will give us 33.7 degree. So we are done with part A. Let's start part B. The force F3 is now removed and is replaced by force F4. So this is F4. The three forces F1, F2 and F4 act on the particle P. The acceleration has a magnitude of this. Find the value of lambda. So we need the value for lambda. So the A is given. The mass of the object was 4. So if we need to calculate the magnitude of the resultant force, F equals ma. So the magnitude of the resultant force is m is 4, a is 3.25. So that's 13. So this is actually the magnitude of the resultant force. So next we can actually calculate this resultant force, which is the sum of F1, F2 and F3. So F1, F2 and F4. F4, this one. So if we simplify this one, we get 5i2j, 3ij lambda I, 3 lambda j. So next I will just take all the I related terms in one bracket. So 5 minus 3 plus lambda I. J related coefficients. So 2 minus plus 1 plus 3 lambda j. So that's 2 plus lambda and 3 plus 3 lambda. So this is the vector format of the resultant force in terms of I and j obviously, but this 13 is the scalar version, which is the magnitude of the force only. So if we try to calculate the magnitude here, that should be the modulus of this, right? So the modulus of any vector is x square plus y square, which are the coefficients of I and j. So which is 2 plus lambda and 3 plus 3 lambda. So if we just expand them using the formula a plus b whole square, so a square 2ab b square, that's for the first part. Next, for the second one, we get a square 2ab plus b square. Next I will just simplify this thing. So the magnitude here is actually, we know the value for that numerical value, which is 13. So we can actually substitute 13 here. So shifting this root at the left side, we will get 13 square So solving this quadratic equation, we will get the value for lambda. The two values are minus 26/5 and 3. In this question, they have already mentioned that lambda is a positive constant. So for that reason, we need to discard this value. So the final value is 3. So we're done with number 3. So let's start number 4. So we have a large bucket. The mass of the bucket is 15 kg. Then the bucket is attached with a vertical cable. When the bucket is on the ground, a bag of cement of 25 kg is placed. So let me just draw the weights. So the mass of the bucket is 15 kg and weight is basically mg. So we have a weight of 15g just for the bucket. Mass of the cement is 25 kg. So the weight of the cement will be 25g. The bucket with the bag of cement moves vertically upward with a constant acceleration of 0.2. So they are moving vertically upward with an acceleration of 0.2 meter per second square. So we need to find the tension in the cable. So the tension acts away from the body. The tension in this case is acting upward. So since they are moving in an upward direction, for that reason I will select upward as the positive direction. So for part A, if I use the formula F equals ma, at the positive direction we have tension and we have two different forces, the downward forces 25g minus 25 minus 15, because they are opposite to my selected direction. Since I'm using the entire system, the mass should be the total mass 25 plus 15 and acceleration is 0.2. So solving this will give us the value for the tension. So tension is 800 Newton. Let's start part B. At the top of the building, the bag of cement is removed. So we do not have this 25g anymore. And instead of that, a box of tools of mass 12 kg is now placed in the bucket. So now we have a box of tool with a mass of 12 kg. So the weight should be 12g. Later on, the bucket with the box of tool is moving vertically downward. So you can draw a separate diagram for this one. I'm just changing the direction here. So now they will move downward with an deceleration of 0.1. So that's why minus 0.1 meter per second square, since they are decelerating. It's negative acceleration. Air resistance is negligible. We need to calculate the magnitude of the normal reaction between the bucket and the box of tool. So for part A, we actually considered the entire thing. So that's why we had to include this tension and all. But now we will be just working with the box of tools, because we need to calculate the normal reaction force between the bucket and the box of tools. So we have a contact force here. So for the box of tools, we have a weight of 12g, and since they have a contact with the bottom of the bucket, there will be a reaction force R. We do not need to consider the tension or the weights of the bucket because I'm using the free body diagram of the box of tools only. So considering this box only, we can use the formula F equals ma. It's moving downward with an acceleration of minus 0.1. Since it is moving downward, I will select downward as my positive direction. Like, it's easier if you always select the direction of motion as your positive direction. So we have weight, so that will be positive because it's downward. The reaction is upward, so minus R. Mass of the box of tools only, that's 12. A is minus 0.1. So normal reaction force is 119. As you have already noticed that for part B, I have used this box of tools only instead of the entire system. That's because we had to calculate this reaction force, right? So if you actually can include the entire system, in that case, you cannot calculate the reaction force, because this reaction force is exerted by this bucket on the box of tools. Similarly, there is an equal and opposite force exerted by the box of tool on the bottom of the bucket. So if you consider the entire system, there will be an equation where you would have calculated plus R minus R, because they are in opposite direction, and it will be cancelled out. So that's why you have to use the box of tools specifically for part B. You have to use the free body diagram for the box of tools here. In that case, you can calculate the normal reaction force exerted by the bottom of the bucket on the box of tools. And as you know that for a free body diagram, we actually include forces which are directly acting on that particle, right? So for that's why I had to use only 12G and R. We didn't include tension, we didn't include the weight of the bucket, any extra forces that are not directly acting on this object. You have to neglect those forces. So yeah, I'm done with number 4. Number 5 is from the chapter vector. We have this particle P moving with constant acceleration. At 2 p.m. the velocity is 3I5J. Then at 2:30 the velocity is 1 plus 7J. So this point can be considered as the starting point. So the velocity at this point is the initial velocity. Let me denote it by U. Then at 2:30 this is the final velocity. So after t hours, P is moving in the direction this. We need to calculate t. So let me just start with calculating the acceleration. So acceleration is the rate of change of velocity, v minus u by t. So let me just use the values of this final velocity and the initial velocity. So I have just substituted the values for v and u, and from 2 p.m. to 2:30 we have 30 minutes, and since everything is in kilometer per hour, the unit is in hours, so it's basically 30 by 60, which is half an hour. So that's why value of t should be half here. Next, I will just simplify this. We have 1 plus 7j, then I need to multiply this minus 1. So that will be minus 3i minus 5j. The signs will be reversed. So this I and minus 3i will give us minus 2i. Next we have 7j and minus 5j. That's 2j. So this half at the denominator, if we just reverse it, we need to multiply with 2. So, or you can even separate this fractions, 2 by half I, then 2 by half j. So eventually we will get 4 minus 4i 4j. Okay, so we just calculated the value for acceleration, but actually we need t, and p is moving in the direction this. A direction is given here. So p, we can use that concept of parallel vectors. For parallel vectors, it's basically x1 by x2, y1 by y2. Since we have I and j, you can actually take the coefficients of I at the left side and coefficients of j at the right side. So it's basically I by I, j by j, as in the coefficients of the I coordinates, the coefficients of the j will be, the ratio of these coefficients will be equal. Okay, so for that, we actually need the value for the velocity. Velocity at time t. So v equals u plus at. U is this. acceleration is minus 4i4j, and t is in terms of capital T. So if we simplify this and multiply this t with both of these coordinates, we get minus 4ti 4tj. So if I just combine the I coordinates in one bracket, we get 3 minus 4t, as in the coefficients of I coordinates in one bracket. Similarly, I will just take the coefficients of the j coordinates in another bracket, which are 5 and 4t. So this is actually the velocity in terms of capital T. So this is the equation of velocity in terms of t, and the particle is moving in the direction this. So this final velocity is actually parallel to this direction. So we just need to take the ratio of the coefficients for both these equations. So we have 3 minus 4t here, 3 minus 4t divided by, we have minus I, right? So minus 1. So the coefficient should be minus 1. For the second part, the coefficient of j is 5 plus 4t, and we have 2j. So we just need to take the coefficients, which is 2. So now just solving this equation will give us the value for t. So I will just cross multiply this thing here. So t is 11 by 4. Next, for part B, we have a different particle q, and the general equation of the velocity after t hours is given here for the second particle. And given that there is an instant when the velocity of p is equal to the velocity of q. So we already have the equation for the velocity of particle p, and the second particle q, the velocity is given. So since it's already mentioned that the velocities are equal, we can just equate these two equations. So basically Vp equals to Vq. So this is the equation for Vp, and then velocity of particle p, and then that's Vq. So I have just substituted the equations for the velocities of particle p and q, and since it's the velocity after a certain time duration, so you can use either capital T or small t. We are talking about one single instant, so that's why we need to use the same letter here. Okay, so since these are equal vectors, as you can see, we need to compare the coefficients of I and the coefficients of j on both sides of the equation. So if we actually pick the coefficients for I, we have 3 minus 4t at the left side and minus 4 minus 2t at the right side. So let's equate them. So we have t equals 3.5. Next, we need to compare the coefficients of j. And we can actually substitute the value for t. After simplifying, we will just substitute the value for t. So that gives us mu equals 8.5. Let's start number 6. So a fixed rough plane is inclined to the horizontal, and tan theta is 5 by 12. Particle of mass 6 kg is projected with a speed of 5 from a point A up to a line of greatest slope of the plane. The coefficient of friction, which is the mu, is given 1 by 4. and the speed is the initial speed u, mass is 6 kg, m is 6. So at first we need to calculate the magnitude of the frictional force on the particle as it moves up the plane. Okay, so the particle was basically projected from a point A. So let's assume this is the point A and the particle is projected from here in this direction up the plane. The weight of the particle will act vertically downward. Weight is mg, so weight should be 6g. So u is actually 5. So in this inclined plane, I will just use this direction along the plane as the x-axis, and the perpendicular direction to this plane is as the y-axis. So let me just draw the x-axis and the y-axis. This angle theta is actually equal to this point as an angle between the weight and this y direction. So we need to break down the component here. So starting from here, you need to reach this end point. So you need to go in this negative y and then down the plane. So the component adjacent to the angle will be f cos theta. So 6g cos theta, and the one opposite to that, opposite to the angle, this one is f sin theta, the formula. So 6g sin theta. Because of the contact here between the particle and the plane, there will be a reaction force acting perpendicular to the plane, which is this, let's denote it as R. Since the particle is moving upward, so the frictional force acts opposite to the motion. So that's why the frictional force in this case will be down the plane, and the value for the frictional force is mu R. Okay, so at first, since there is no movement in the y direction, in this direction, so in this direction, upward force will be equal to the downward force. So we have R and 6g cos theta. So if I just write down the equation, we should get R equals 6g cos theta. So we need the value for cos theta sin theta, right? So it was already given that tan theta is 5/12. It means tan is opposite by adjacent, so this 5 is the opposite direction and opposite side, and 12 is the adjacent. So if I just draw a triangle, this is the opposite side and that's the adjacent. So using Pythagoras, you can actually calculate the hypotenuse, or opposite square plus adjacent square, so that will give us 13. So from this triangle, we can actually find the value for sin theta and cos theta. Sin theta is opposite by hypotenuse, so opposite side is 5 and this 13 is the hypotenuse. Cos is adjacent by hypotenuse, so 12/13. So we can substitute that value here, 12/13, so 6g into 12/13. So that will give us 72/13g. So the frictional force is mu R. Mu was already given. Mu was 1/4 and reaction force is 72/13g. That's 18/13g. So we are done with part A. Next, the particle comes to instantaneous rest at point B. So particle was thrown from point A in this direction. After moving a certain distance, let's assume this point to be B, and the particle comes to rest at this point. So final velocity will be 0. So we already have value for u, initial velocity 5, final velocity is 0. So we need to calculate this distance AB. We need to calculate this distance AB, and for that, the first step is to calculate the value for A. So since the particle is moving in this upward, up the plane direction, so let's assume that direction as positive, and I will apply F equals ma. Since the particle, you just projected the particle, it's not like you are actually pushing this particle and helping it to move forward. So there is no constant force acting on the particle in this direction. You just projected it, so there is no constant force. So we have zero force in this up direction, up the plane, but down the plane we have component of weight and the frictional force. We have two forces acting opposite to the motion, 6g sine theta and mu r. And since there is no force acting on the particle in the direction of movement, so that's 0, and we have two forces down the plane. Mass is 6. We need to calculate A. So we can substitute the values here. Sine theta is 5/13. Mu r is actually the frictional force, which we have already calculated in part A. So 18/13g equals 6A. So next I will just simplify this one. Dividing the 6 at the left side, we will get A equals minus 8/13g. So we can actually use v square u square 2as. V is 0, as mentioned here. It actually comes to rest, and initial velocity was 5. So v0 u5, A is this one, minus 8/13g. Distance is what we are trying to find, distance AB. So we can cancel out the negative sign, and substituting the value of g and subjecting s will give us the value for the distance, which is 2.07. So for part C, there are some extra information given here. The particle will now slide down the plane from point B. So this point is the starting point now. So the particle will start moving from B down the plane, and at the instant when the particle passes through point C, the speed of the particle is 5. So after covering a certain distance, there will be a point that's assumed it to be here. The velocity will be 5 again. So from point B, this is the initial point, so u should be 0. The v for part B is now the u. So u is 0. The particle starts from rest, and then it moves down the plane, and we need to calculate the distance BC, as in this location, and the final velocity is 5. So the situation is more or less the same thing. It's just that we already have the value for u, we have the value for v, we need the value for A. So the particle will move down the plane. So the forces here are, the values are same. The frictional force is still 18/13g because the reaction force is same, the mu is same. But the point is, now that the particle will move down the plane, so frictional force will act up the plane. So the frictional force is now up the plane. Okay, and the component of the weight which acts down the plane is still in the same direction, acting in the same direction. So now the particle will move down the plane. I will select this direction as the positive one. So if I apply F equals ma, the component of the weight, which is this one, 6g sine theta, is positive, and frictional force is negative. It's acting up the plane now. Frictional force value is same, 18/13g equals ma. So we need to calculate the new value for A, and we can substitute the value for sine theta, which is 5/13. So A is 2/13g. It's positive because the particle is now accelerating down the plane. And next we can just use those values in the formula. So u0, v5, acceleration is 2/13. So let's use the formula v square u square 2as. And we're done with number 6. Number 7 is from the topic moment. We have this non-uniform beam AB. Non-uniform means it's not symmetrical and the weight will not act from the center. The mass is 60 and the total length is 8a. The beam is in equilibrium in a horizontal position on two vertical support. One support is at A, AC is A meter. Then the other support is at D, dB is 2a. So in between this distance should be 8 minus a and 2a, so this should be 6a. The magnitude of the normal reaction between the beam and the support at D is 3 times the magnitude of the normal reaction of the beam and the support C. As in the normal reaction at D is 3 times the normal reaction at C. So it's just that the normal reaction at point D will be thrice of the normal reaction at point C. So if we consider the normal reaction at C as R, in that case at point D this will be 3 times of that, so 3R. This point is C, that's D. The center of the mass is at a distance of x meter from A. So let's assume that this is the point from where the weight will act, and this distance from A is actually x as mentioned in the question, and the weight is 60 g mg. So mass is 60, so weight should be 60 g. For part A, we need to find an expression for x in terms of A. So the first step is to calculate the value for R. So since the beam is in equilibrium position, so the upward forces, all the upward forces will be equal to the downward forces. These are balanced. So we have two upward forces, R plus 3R, that should be equal to 60 g. So the value for R is 15 g. Since the beam is in an equilibrium position, the sum of the clockwise and the anti-clockwise moments will be 0. I will select the clockwise moment as positive and all the anti-clockwise moments will be negative. So I can select any random point and the sum of the moment about that point should be 0. I will be selecting point A. In that case, we can directly get an expression for x easily, because this distance x is actually given from point A. So let's write an equation of the moment about point A. So considering this point, the reaction force at point C is actually creating an anti-clockwise moment. So minus moment is what? Force into distance. So minus R, force is R, and this distance is given A. Then this 60 is actually giving a clockwise moment, so positive. Force is 60 g, the weight, and the distance A, and this point is actually x. Next, for point D, this 3R is given an anti-clockwise moment, so minus, and the distance AD, we need the distance AD. The total distance is 8a and we need the distance for AD. So 8a minus 2a, that's 6a. So AD is actually 6a equals 0. You can even use the clockwise moment at one side and the anti-clockwise moment at the other side. It's the same equation. I will just add this RA, that's actually 19 RA, and I will shift this at the right side, so that will be positive. Next, we will just replace the value of R which is 15G. So we can actually cancel out G from both sides. So that's 19 by 60A. So we are done with part A. Next, for part B, the situation has changed. This box of mass M is now placed at point E. A is to A. So for that, let me just draw a new diagram. So we have this beam AB, and we have two supports at C and D. The box of mass M kg is placed at point E. AE is 2A. So this is E. AE is 2A. AC is A. It was initially mentioned. DB is 2A. Then the magnitude of the normal reaction at C is now equal to that of D. So the reaction force are now equal. So R, we need to calculate the value for M. And the weight of this beam, which was 60G from X meter from A, right? So those situations are same, those are unchanged. So let's use this point 60G, and from A this total distance is actually X. Okay, so this is the new diagram, and we will do the same thing. We will just use an equation for the upward and downward first. So since the beam is an equilibrium, so there is no resultant force in the vertical direction. So if I just equate them, sum of the upward force equals downward. Upward we have two forces, reactions, and downward we have actually we have this box mass M here, right? So the weight should be mg. So mg plus the weight of the box 60G. So we get 2r mg plus 60G. So from here we get an expression for r, actually mg plus 60G divided by 2. So you can even simplify this, or let me just keep this thing like that. Next we need to find an equation for moment, because we need to solve this, right? So you can consider any point, since all the distance are measured from A. So it's easier if I just select moment at A. So from this location A, this reaction is giving an anti-clockwise moment, so minus r into A. Then this mg is giving a clockwise moment, mg into 2A. The 60G is also a clockwise moment, 60G into distance is x. Then this D, at D the reaction force, it's anti-clockwise, so minus r into the distance AD. Total distance was 8A, so 2A, if you deduct 2A, then you get AD 6A. Next we need to just simplify this one. So minus RA 2mGA plus 60GX. X is 19 by 4A minus 6RA. So we can add this R, so we get minus 7RA 2mGA 285GA equals 0. We can actually factorize and take A out of this equation and then shift A at the right side, and it becomes 0. So we can shift this A, we can just take this A like this, minus 7R 2mg 258g equals 0, and then you just shift this A at the right side, so it becomes 0. So next we will just substitute the value of R here and then solve this equation. So mg 60g by 2 So next 7 into 60 divided by 2, that's 210 G. Next we can actually factorize and take this G out of this equation and shift to the right side to make it 0. Then we are left with minus 7 by 2m, 210, 2m, 258. Okay, sorry, there is a correction. Instead of 285G, I actually used 258. So this is the correct value, 285. So if we use this one, ultimately we will be getting a value for m, which is 50. And that's the end of this math. Number 8 is based on speed time graph. So we have two tram A and tram B. Initially two trams are at rest, and when t equals 0, A starts to move. A moves with constant acceleration of 2 for 5 seconds. So eventually we need to sketch, right? So let me just start with that one. Okay, so the tram A moves with constant acceleration of 2 for 5 seconds. So since it's moving with constant acceleration, we should draw a straight line over here for time up to 5 seconds. Okay, next it then continues to move at that same speed. So that's why we will just draw a horizontal line, because velocity is not increasing or decreasing. Okay, speed is constant, so that's why it should be a horizontal line. There is no increase or decrease in the speed. Okay, next we have the second tram B, and at time t20 it starts from rest. So the journey of the second tram should start at 20. So if this is 5, then 10, 15, let's assume 20 to be here. So it starts from 20, then constant acceleration 3 meter per second square for 4 seconds. Okay, so it has an acceleration of 3, which is greater than 2, so it should be a little bit steeper. And for 4 seconds, right? So 20 plus 4, so this final point should be 24. 4 second acceleration. Then it continues with the constant speed. Okay, so we are done with the speed time graph. Next, let's start part B. So for part B, at the instant when the two trams are moving with the same speed, tram A is d meters in front of tram B. So the first point we should notice is that they are moving at the same speed. So when did that happen? We need to find that time, right? So since this is a speed time graph, the intersecting point of this graph is actually is the point when they are moving at the same speed, and that speed we can actually calculate that point, right? The velocity here, we can actually find the value from here. V equals u plus at. U is 0, starting point. Acceleration 2 times 5, these were given, so we can substitute that one here. 5, 2, so 10. So this velocity is actually 10. Okay, so this velocity is 10. So we need the time duration. We are working with this point, this specific point. So at that point, v is 10, u is 0, acceleration is given 3, and we need to find the time. As in, we cannot use that 4 seconds. We are not trying to work with that point. We need the location when speed is same, which is this intersecting point. So velocity, final velocity v, initial velocity u. So from there we can find t, which is actually 10 by 3. T is 10 by 3, which means from 0 to 10, the tram took 10 by 3 seconds to reach a speed of 10. Okay, so this is 20, so 20 plus 10 by 3 will give us this instant, which is 70 by 3. So tram A is d meter in front of tram B. So it means if this is point A, B, let's assume this is the starting point. So B has traveled some distance, A has also traveled some distance. It has already mentioned that tram A is d meter in front of tram B. It means A has traveled more distance, right? So the gap between them is actually d. So A is d meter in front of B. So if I find the distance traveled by A, distance traveled by B, the difference should be d. Okay, so next I will just try to find the distance traveled by A and B up to this point, 70/3, because that's when their velocity was 10, as in they were moving with the same velocity, with the common velocity of 10. Okay, so next I will just try to find the area under the curve for both this situation, because area under the curve gives us the distance here. So let me start with the first one, tram A. Okay, so up to 70/3, this is the diagram for tram A. If I need to find the area under the graph, this is a trapezium, so half A plus B into H. So A and B are the parallel sides. So A is this gap, so 70/3 minus 5. And B is this total base of the trapezium, which is 70/3. And the height, perpendicular height, is 10. So that's 50/3. So next I will try to find the distance traveled by tram B up to this point, so which is basically a triangle. Okay, so we will find the area of this right angle triangle. So for the triangle, this base of the triangle is actually 10/3, and the height of the triangle, this portion, is 10. So this is a vertical and horizontal lines. These are vertical, horizontal, so these are perpendicular to each other. It's a right angle triangle. So the area under the graph should be half into base into height. So half into 10/3 into 10. So that's 50/3. This one is, sorry, let me just, we have a correction here. That value should be 625/3. We need to find the value of D. So D is this difference between them. So we will just deduct this two distances, 625/3 minus this value. So the distance is 625/3 minus 50/3, which is 575/3. Since the numerator is greater than denominator, I will just write that value as a mixed number, so 119 whole 2/3. So that's D. A was d meter in front of B, so the gap between them should be D. So we're done with part B. Part A was this speed time graph. Again, next we need to find the distance of the tram at the instant when B overtakes tram A. So overtaking means they are at the same position and at the same instant. So time and distance should be same. Since we don't know exactly when and where this happens, so let me just assume any random location. So let's assume this is some random location and time at that instant is small t, and that's when they B actually overtakes tram A. So distance traveled by A and B at this point should be equal. So we will just find area twice and then we will just equate them. You can use values directly from this initial diagram, or you can use a separate diagrams like the one I did for part B. This makes things easier. So up to this point, if I just take the trapezium, that's the situation here. So I will just use the trapezium formula. Area for the trapezium, half into A. A is this gap, so that final point is small t. So this gap should be t minus 5, which is this A, and B is the total distance here, which is small t. So half A plus B into H. H is this gap, which is 10. So if we just cancel this out, we get a 5, and inside the bracket t plus t, it's 2t minus 5. So the final value should be 10t minus 25. So this is the distance traveled by tram A. Next we will find the area for the second tram, area under the graph up to this location. For the second tram, if I consider area up to this point, this time is 20, 24, then that final point is small t. We need this value, right? This value, which should be the height actually. So this final velocity, so v equals u plus at. U is 0, starting from 0 here. Time is 20, but velocity or speed at this point is 0. Acceleration for this one was 3 and time was 4. So 3 into 4. So that gives us 12. So we can use the formula for area of the trapezium. So half A plus B. A is this gap, as in this portion, which is t minus 24. Then B is this base of this trapezium, which is t minus 20, as in A, B, t minus 20, and height is 12. So if we cancel it out, we get 6. Inside the bracket, we have t plus t, 2t minus 44. So if we multiply this whole thing by 6, we get 12t minus 264. Okay, so since B, this is for tram B, since B overtakes tram A, it means distance traveled by them should be equal. So we will just equate these two values. Since B overtakes A, so that's why we can just equate these values. So 10t minus 25 equals 12t minus 264. So we got t equals 119.5, and we actually have to find the distance of the tram when B overtakes A. So since they are at the same location, we can substitute this t in either of this equation, because both of them will give us the same distance. So let me just use this first one, 10t minus 25. So we will just substitute the value of t. That's 1170 meter. Well, I'm done with number 8, and that's the end of this paper. So this was a complete solution of M1 May 2021, and I hope this was helpful.